There we go. All right, good morning, everybody. Today is Monday, October 6th, and we have finished our work with MATLAB, and we're going to start using Excel. Now, when I say we've finished our work with MATLAB, we also are going to have our midterm exam this afternoon in the lab beginning at 2 p.m. So if anything is interfering with your ability to be in class, in lab this afternoon between 2 and 3 p.m., please let me know and I'll make another arrangement to proctor you at a different time to do our MATLAB assessment, which basically is our midterm exam. The other thing in terms of scheduling is that we are almost to midterm. This is midterm week, so we don't have class Friday of this week or Monday of next week. So Monday the 13th, there's no class for anybody on campus, which means that we don't have lecture or lab on Monday, but we will have lecture and lab today, and then we will also have lecture on Wednesday. So what we're going to do right now is to begin our work with Excel. And the book that we're going to be using is the one that was assigned for you to purchase at the beginning of the year. Let's see if I'm able to do this. No, all right. So anyway, what you see on the screen is just the first page of chapter 1. And this is what's available to you. But the basic way that we're going to go through this is we're going to work through the chapters. And then at the end, and interspersed throughout the chapter, sometimes we have questions and problems. So here's problem 1.1. We go through and read some more stuff. There's examples and so forth. And yeah, graphing is so cool in Excel. You will love it. You will absolutely love it. So then we have some more problems. You don't really have to know very much about an electric circuit in order to do this problem because the material is given to you. But basically, if you look at this problem that we have on the screen right now, I'm just going to point to some elements, although it will be defined. This structure is the way that they draw it. This diagram is the battery. V stands for the voltage across that battery. I is a current. Current splits at a node right here, so that, for example, we have some of current I going across this resistor, which this is a resistor, and then part of the current going across here. So current is conserved through a node. So basically I is equal to I1 plus I2. Okay. And that's referred to as Kirchhoff's current law, KCL. So then we have resistors across each resistor. The equation is that V is equal to IR. And so you're able to determine everything. You're able to find all of the unknowns based on the givens in this problem. But so you need to use V equals IR. And I is equal to I1 plus I2. And if you use those two equations with the circuit, you're going to be able to do that analysis.
Why are the resistors multiplying the voltage?
They don't multiply the voltage. What happens across, excuse me.
Sorry, they are IR.
Mm-hmm.
So
A
current,
voltage is equal to current times resistance. What that means is that if you have more resistance in a circuit, you're going to need more voltage to drive the same amount of current. Or you're going to need more current to get the same voltage. This is this is just the basic law. I can't remember the name of it. Isn't that crazy? It's escaping me. Hang on just a second. Ohm's law. Thank you. Oh my goodness. All right. It was just escaping me and I could not remember it for whatever reason. So, but yeah, that is, so we use, let's just write this on the board, Ohm's law, which is a governing law of electricity, is that across any appliance, whether it's a resistor, any element of a circuit, voltage is equal to current times resistance. Then we use Kirchhoff's current law, which says current splits at a node. So in the case of this circuit, I, which is what's going in, is equal to I1 plus I2. And there's another one that's called Kirchhoff's voltage law, which you're not going to need in this particular circuit. But those are sort of the governing equations of basic circuitry. When you take electric circuit theory or electric circuit analysis, you obviously will learn a lot more, but this will get you quite a ways when you're analyzing basic electric circuits. Okay, so you know the other good news about electricity is, and Jace, I know that you had a visceral reaction to British units and metric units and sort of the fact that nobody uses the same thing. Electricity was developed late enough that until you get into units of power like horsepower and decatherms and some interesting things like that, whenever you're analyzing circuits, everything's pretty much consistent. So V is measured in volts. I is measured in amps, and resistance is measured in ohms. And if you stay, the only thing that they really do is they might have kilovolts, which is 1,000 volts, or milliamps, which is, or mega ohms, maybe. And that's the symbol for ohms. That's just the Greek letter omega. So the good news is that the units are almost always consistent until you start talking about horsepower or some sort of a prime mover sort of a thing. So that's the good news. But anyway, so this is, we're going to be using Excel. For those of you who've used Excel in the past, we're going to jump right into problem solving with Excel. So Excel is great for just adding up columns of numbers. It's also great for a lot of other things that are much more advanced. But so for our work together, and all of this will be posted on our Moodle page, we can see that we have, like I said, Ohm's law, V equals IR, Kirchhoff's law, which tells us about resistance and voltage and also current right here. And then we talk about resistors in parallel or resistors in series. And we'll talk, we don't really need to know very much about that right now. But basically, all of these problems, the equations to solve these electrical problems are given to you in this particular chapter. So our process for this chapter and for every chapter that we cover is we're going to, you read the material, and when you encounter a problem, you do it in a spreadsheet. Everything that you submit to me has to be submitted in an Excel spreadsheet. Google Sheets is not acceptable. Okay, only Excel is acceptable, and you do have access to that through your student account here at the college. The reason that we don't use Google Sheets is because at some point you're going to come up with a lack of functionality or something that behaves differently than the way the book tells you to do, and it's not going to do what you need it to do. So at the beginning, it absolutely will, but I don't want you to get started with it. I want you to get started with Excel and use it clear out of the chute. All right, so what is the, so if you look at this, so we looked at problem 1.1, 1.2, and then the end of the chapter problems go down to problem 1.11. So the assignment for chapter 1 is to work through all those problems. And that's what we're going to do in lab this afternoon. Okay, and I'll have the due dates and I'll have the assignments posted. So there will be no ambiguity about what is expected of you. All right, so let's take a look. Having said all of that, let's take a look at what Excel looks like and what can Excel do for you. Some of you, I shouldn't say assume, but Excel, people's ability or experience, I guess would be a better way to put it with Excel, is kind of all over the place. And some people have never opened it up, and some people have used it extensively for different things in their lives. So the way that Excel works, I'm just going to show you some really basic functions, is that the columns, which means going up and down, just like a column supporting a roof line, are labeled with letters. Rows are labeled with numbers. And an individual cell is a combination of a column and a row. So for example, the cell that I'm in right now, is E7, and you can see that right here. Right? Now you can do a lot of different things. You can put a word in here. You can put a number in here such as 6. And then you could put another number such as 7 over here, and then you could add them with a function. Okay, so for example, you could say that this cell, when you're going to do a function, you always start it with an equal sign. So I could say equals E9 plus F9, which will take the contents of cell E9 and add it to the cell F9 and give you a total. Now, what is the advantage to this rather than just saying equal 6 plus 7 or just writing 13? Well, the answer is that if I change this number also changes. Okay. Now, another thing that happens is what is called a relative cell address. So let's just do something else. Let's just say I have a series of numbers. Let's just do this. So I start with a number 1 up in this column. And then here, instead of writing out 369, I want to add up a whole bunch of odd numbers. So I can say that this cell equals A1, cell A1 plus the number 2. So this will give me, oh, I put 3, hang on, plus 2. So that'll give me the value of 3. Now, instead of doing that every single time, I can just take this cell and I can copy it, Control C, copy it down. And you can see that I'll keep adding and adding and adding 2 so that I have a whole bunch of even numbers in these cells. Now here, if I want to add up the content of all of these
What
cells,
was the original?
just 1. I just put in the number 1.
What is number 2 set to?
Ah. The content of cell A1 plus 2. So that's,
Everyone is A1 plus 2, shouldn't they?
no, now see, this is the next part. Well, look what happens to the next cell. It becomes A2 plus 2, A3 plus 2. This is called relative cell addresses. Okay, that means that it's really saying here I'm taking the cell above it and adding 2. So here I'm going to take the cell above it and add 2. What if I always wanted it to be A1 plus 2? Then I have to anchor that cell address, and you do that with $signs. So in other words, let's do this. If I copy, I'm going to copy these 2 cells over, Control C, look what happens. This becomes B1, look at the formula, it becomes B1. What if I don't want it to be B2, B3, I always want it to be B1? You put a $sign in front of the column and a $sign in front of the 1, and it anchors it so that it's 3. Now, if I copy it, it's going to be anchored, and it's always going to be A1.
So when you typed A1, it, without the anchor, it just implied that that was relative.
That is correct. That's right, the default is relative cell address. The default is not an anchored cell address or absolute cell address. Absolutely. And it's very handy when you're adding columns of numbers.
Because why would you want a bunch of problems with the same?
Well, let's say, okay, that's a great, let me show you an example. Let's just say that you were calculating interest on a loan. This is going to be very simple. I actually, when I first moved back here at Powell, I built an amortization sheet for realtors. Now you can do it online. You can do it a million different times. But I was doing a bunch of projects. One of the companies I worked for was a realtor. And I made a spreadsheet where you could put in amount of a loan, terms of the loan, how long you were going to pay, whether you're going to pay monthly or bi-yearly or whatever, and then the interest rate. And then it would calculate a payment and how long it would take you to pay it off, what the payment would be, blah, blah, blah. So you want to anchor those numbers, right? But then for the months, you want it to calculate based on the month before. And it's a little bit more complicated than what I want to show you today, but that was a really cool thing. Now you can do it easily. Now there's amortization calculators all over the place. But at that time, that was kind of it was kind of a convenience for realtors, because otherwise they would call a banker, and the banker would have to do the calculation, and then they would tell their client after they found that. But after they had a spreadsheet, they could just do it whenever they felt like it. But so let's just say interest on a loan. For example, let's say that you want to have 5%. Okay. Now, the first thing is you can put in a percent sign. If you write 5% with keys, you want to keep this numeric. In other words, you don't want to put in the percent sign, what you want to do is to format that cell as a percent. Okay, so instead of putting in the percent sign here, you just tell it it is a percentage. And there you go. So 5 is 500%, 0.05 is 5%. Okay. There you go. So you have a 5% loan. Let's say this, interest rate. Term of loan. And let's just say. 6 years and then, payments per term. If you want to have a year, that'd be 12. Oh, and then you can stretch this out too, very easily. Okay, so if you want to make this bigger so you can read everything, and then, you could say the principal, how much you're borrowing. Let's say you're borrowing, in this case, $100,000. Once again, you want to format that, so you just right click it and go to format. You're gonna learn all this. I'm not gonna make you do this all today. I'm just showing you how this works. So there's $100,000. And then you might want to just have the payment. Okay, and this is just simple interest. We're not gonna do, there is a formula for compound interest, which is how banks calculate it. But we're just gonna say simple interest. In order to find a payment based on simple interest, the formula is, I'll just write this out, payment times, excuse me, not the payment, I'm sorry, the principal times the interest rate divided by the number of payments. Basically, let me find this formula for simple formula
I
for
think
payment.
compound interest is starting amount times interest rate to the power of.
Oh, I'll show you what it is, just a second, but I just want to do it. So the simple interest calculator is this, A is equal to principal times 1 plus RT. Okay, where this is the rate and this is the amount of time. Okay, so if you look at the calculator here, A is the total accrued amount, which is the principal plus interest. Okay, so I want to have. Oh, this is just gonna do that. Okay, that's the total accrued. All right, so what you can do then is just put those numbers in, but you may want to change the principal, or you may want to change the interest rate, you may want to change something, and then you'll be, this is an accrued number. I really would like to get the payment. Hang on just a second. Payments. And then I'll show you. Loan payment, simple. Let's see if we can do it. Okay. And this is what you're talking about in terms of the payment, for an amortization table. So let me take a look at this here, just a second. Bring this over. And get out of this browser, I'm gonna come back here. To my file explorer went away for some reason, but let's come over here. I'm gonna stop sharing for just a second so I can see my top bar. Yeah, there we go. Okay, so. Let's see, there it is. There's the amortization sheet table that I made. This was a while ago, but let's take a look at it. Take a while to pull it up. There we go. All right, so here we go. Let me share again. And I want to. So this is basically, this is where we have a $200,000 payment, or house, the principal of the house. How much money you put down as a down payment, so that's the loan amount. So you see the first formula right there, right? You subtract the down payment from the amount of how much the house costs. Then you put in how many years and at what percent you want. And then it gives you a table showing you the beginning principal, the payment amount, which should be the same, basically, mortgages always have the same payment. And then how much of that was interest, how much was principal retired, and then you have an interest ending principal. So basically, if you look at this, the payment is going to be based upon the calculated payment, which is this formula. And Jace, that's what you were talking about right there. All right, now the other part is that you can put in these numbers yourself, or Excel has a series of, not a series, it has a suite of functions that you can use that are already built in, and PMT is one of them. So you can do it that way as well. But the one thing I think that you were alluding to is if you look at the amount of the interest on payments, that you start out paying a great deal of interest. And as you go down, you pay less and less interest every month until at the very end, however many years, this is a 20-year mortgage, but at the end, you can see that you have no more principal to retire, which is expression, and that your last payment, the amount of the payment is identical to the payment that you've been making, and so then you pay off the loan. Okay, so is that the question you were asking? Jace? What was the question you were asking?
I don't remember.
Oh, okay.
I don't think I had a question. I think I just-
You were just talking.
Yeah.
All right, that's fine. Yes, sir.
Put that on
What, this program?
the spreadsheet.
Yeah, absolutely. I'll put it up for you guys. Yeah. It's very handy. I mean, and you can use it for a lot of different things, so. Yes, and it was very simple. The only thing is, of course, that the number of, I did not put in a feature. Excel will do this, where it'll cut off at a certain number of payments. I let it go because if you want to make it a shorter period, like you're gonna buy a car, cars are generally bought for 6 years, 72 months, and so you can just see, instead of going down all the way, you would have a bunch of zeros and negatives after 72 months.
Yeah.
So, but you can
You can figure
adjust
it out.
absolutely, that's right. So, but yeah, I'll put that up for you guys. Absolutely. So Excel can do a lot of really cool things for you. Another thing that Excel can do is a bunch of statistical functions. When you get into statistics, which I don't think are any of you in civil engineering? No civils. What major? You're in civil. You'll do statistics if you're not in statistics already. Okay, so statistics, you can use Excel for a lot of stuff. There's a lot of statistical analysis programs, but a lot of times when there's one program that's used for heavy duty statistics, which is called SPSS. And SPSS has been around since literally the times when they used cards to put data in punch cards, like the ones that say don't spindle, fold, or mutilate. And they just sort of added on to SPSS, so it's extraordinarily powerful, but not everybody has it. And it's also quite expensive. So almost anything that you want to do with statistical analysis, you can do in Excel as well. So having said that, if you take a look at our book, you'll see that we're going to go through many of the chapters, and I will post everything that we go through. But chapter 1 in our book is engineering analysis and spreadsheets, which is why we take a look at a little bit of geometry. We take a look at a little bit of electric circuit theory. Chapter 2 talks about creating an Excel worksheet and so forth. But every week, what we're going to do is work through a chapter or maybe a little bit more of the textbook. So it'll be a combination where we discuss the ideas in lecture. And then I show you some examples, and then in lab, we go ahead and do the whole thing. So if you play your cards right, you won't have any homework for the rest of the semester. So that would be nice. You could do it all in lab. Yes, that's better, right? It's better if you can just do it all at one sitting. In the next, I'm gonna take just 5 more minutes at the most, and then I'm gonna turn you guys loose. What I'd like you to know about Excel is, I may have told you this already, but my colleague Tim Glatzer one time said that Excel is not the best tool for anything, but it's the second best tool for almost everything. It is so incredibly versatile. That's reason one that we use it. The other reason is if you go to work as an intern or an engineer or a tech for anybody, the chances that they're going to have Excel on the computer that you sit down at are very, very, very high. If they don't have Excel, they will have Google Docs, which is an inferior product in every way, but it's
It's definitely a web browser, so.
exactly, that's exactly right. Unless they're like floating like it's 1986 and nobody has access to the internet, you're gonna have something.
Then maybe don't work there.
Another good point is like, you are not adequately preparing me to do this job.
Or, double their income to get them to update to.
See, 100%, right, and so, and Excel has been around a long time, the Microsoft, and some people have mixed feelings about Microsoft. I personally love Microsoft because Microsoft standardized the industry. I mean, before Microsoft really became the heir apparent to desktop computing, everything was all over the place. Nothing worked with anything else. I remember, for example, before Word became the preeminent word processing program, there's another word processing program called WordPerfect. And WordPerfect was really, for the time, was more advanced than Word. But one of the things that you had to do with WordPerfect, because there weren't enough internal functions, had a little cardboard template that you would put over the keys on your keyboard physically. And so it would say F1, Shift F1, Alt F1, Control F1, and there'd be those stacks of functions. So if you wanted to copy, you would have to do some sort of a Control or Shift or Alt key with one of the function keys, and that's how you build up functions. So when Microsoft came about and became the heir apparent to desktop computing, it simplified everything because it also built in the idea that certain control sequences, like Control C, almost always means copy, Control X almost always means cut, Control V almost always means paste. That was never standard. You might be in one program, and to cut something, you would have to do some weird sequence and so forth. So Excel and Word and PowerPoint and all of the other programs in the Microsoft suite have really made computing across the board much more accessible to everybody. But I'll guarantee you, if you can use Excel, you will be ready to hit the ground running. And as Jay suggests, if your company doesn't have Excel, perhaps you should work for another company. So I had never thought of it that way, but yes, that I'm not going to argue. I think that's a good point.
Either work for a different company, or you walk in there like, I'm about to blow your guys' mind.
I'm going to show you what it is. Yes. Yes, I wait till, well, there've been a couple of times, and the situation is very much different now, but so when I went to work after I got out of college, when I went to work as an engineer, the first job I ever had, I'd had internships, but the first full-time job I ever had, one of the reasons they hired me was because I had gone through college using computing power, and nobody else had, because they were just a little bit older and it was kind of a new thing. So we had, for example, a report that we had to have, which had thousands of lines of data. And before this, they had always just had a secretary literally type it out on an IBM Selectric typewriter. So I put it into, it wasn't even Excel at the time, it was called Symphony 123, and which was one of the precursors to Excel, that and Lotus, or Symphony and Lotus, which were kind of the same program. And I put it in, and I pretty much stunned everybody by the efficiency of being able to use that program. So There you go. I mean, so there are more stunning opportunities for you that are not that, because that's no longer stunning. But if you organize things in Excel, you will make your life easier. I will guarantee that. All right. So having said that, I'm gonna update our webpage, make sure all the assignments are up to date. I will see you in lab this afternoon at 2-ish, and we'll do your assessment. And aside from that, I hope you guys have a great day. So end of recording.